Measure is to ascertain the dimensions, quantity, or capacity of an object. Dimensions have to do with length or area. I feel like we already did this. We got to a point. Oh, we got to midpoint. Okay, we did. Okay, that's what I thought. No, wait. Sorry, measure's just on this one twice. Okay, so we've got length or area. Quantity is, number, and capacity is volume. An angle, we have not done. An angle is a figure formed by two rays sharing a common endpoint, and that endpoint is called the vertex. So if I have a ray and I have another ray, that's their common endpoint. Now, we talked about the fact that it was really important when you were naming a ray, which letter went on that endpoint where there was no arrow. When you name an angle, it's very important that the vertex is in the center. Okay, so when you name this, you name it as angle ABC, or you can name it angle CBA. But the vertex has to be in the center. Okay, if I said angle BAC, I would be talking about an angle that came up like this and then went down like that. A would be the vertex. So that's really important that the vertex letter is in the center. The other two letters can go either side. Okay. Ray, we already knew the definition of ray. And then we have vertex is the point where the sides of an angle intersect. So ray is like this. And we name it, making sure that the side without an arrow is the endpoint. And then the vertex, if we have an angle, that's the vertex right there. Yes. And this is angle ABC or angle CBA. Just so long as the B is in the center. That's what's important. Okay, so protractor is a semicircular instrument for measuring and constructing angles. An acute angle, sorry about that, is any angle less than 90 degrees. You can remember this because they're little, they're cute. Little things are cute, like little puppies and little kittens. And a right angle is exactly 90 degrees. And an obtuse angle is anything greater than 90 but less than 180. If an angle is greater than 180, when you go around, if I have an angle, let's say like this, and I measure it around this way, it's going to be greater than 180. But if I measure it this way, it's less than 180. It's less than 90. So in this case, this would be acute. We don't actually measure the larger part. So we talk about angles and we only measure them between 0 and 180. Does that make sense? Because the 180 is the straight line. Okay. All right, so here's our protractor postulate, and that says that the rays in a semicircle can be numbered from 0 to 180 so that positive number differences measure angles. Basically, it tells us that we can use this tool, the protractor, and we can measure any angle with it. If you have a straight line would be, pretend that's straight that I'm drawing right there. Straight line is exactly 180 degrees. Okay, we don't really measure a 0-degree angle. Okay, so examples. If we have these angles. This is angle ABC. That's an A there. Or angle ABC with the vertex in the center. Okay. Ray BA and ray BC make the angle ABC. Right. Examples of the vocabulary, we have an acute angle, a right angle, and an obtuse angle. So this is 0 up to 89.9, repeating. Like 89.999999 is still acute. This is exactly 90. And this is like 90.000 something 1. Like as soon as you go above 90, even if it's, now you can't measure this obviously with a protractor. They're not that accurate, but if you had some computer simulation that could measure the angle and it was 90.0000, like a whole bunch of zeros and then 1, it would be obtuse. On up to 180. So this has to be exactly 90. Okay, so we've got those. Now, when we're using a protractor, you read the protractor 2 directions, okay? And it depends on the direction where your angle is opening up from. If your angle is opening up this way, like you start here and you open up like that, you read starting at this 0 and you read around on the inside. If your angle is opening up over this way, like that, you start from 0 here and you read up on the outside. Okay. Now, that was probably really confusing. So, let's look at this. Okay, how to use a protractor. The vertex goes to the center hole in the protractor. And I'm going to show you this with an actual real protractor as well, so that'll help. You line up the bottom or the side, one side of the angle on the line that comes from that center hole. Okay. And then you read the other side. Now, because this is opening and it's going this way, I'm going to use this inner number. So this one's 60. Good check is 90 degrees is straight up and down, right? That's 90 degrees. If you're not, you're smaller than that, then it wouldn't make sense to be 120. So you can kind of check yourself. Like if you accidentally read it wrong, you go 120 degrees, look at the actual angle and go, okay, that's not like a square, so it's got to be smaller than 90. If it's bigger, then it would make sense. Like if it's opening past that squared, then you would want the bigger number. Does that help? Okay. So then we line it up and we find the point, and there we go, 60 degrees. Okay. Let's look at that with an actual real. Right? So we have 2 different kinds of protractors. Usually this is the kind you buy at the store. But you might end up with one of these. We'll start with this one. I'm going to do number 13. Okay. So here's my vertex, and there's that hole right there. So I make sure the vertex is in the hole. Now, as you can see, I'm not lined up properly. If you look, there's like this little line across there, that black line. I want to make sure that that black line is right on top of the angle. Okay. Now when this happens, I look at that and I go, okay, that's too small, I can't even measure it, which is possible. So I use my protractor to actually extend the line. Then I go back and I reline it up and I look and okay, I'm less than that 90. So I'm starting on the inside, and I say, okay, 80, 81, 82, 83, 84. Okay. Now, if you said 83 or 85, I'm not going to count that off because it's close enough. Maybe the line didn't get drawn exactly the same. You know, we're talking 1 degree. But if you said 90 or 60, you know, if you're far off, then it would be an inaccurate measurement. Now with this type of protractor, let's look at number 14. I don't have a hole, but I do have that dot. Do you guys see that dot right there? And then I have this line across the bottom. So I'm going to line the vertex up in that dot and the line of the angle on this line across the bottom. And again, you can see it's not long enough for me to measure. So I'm just going to draw a line out, reline this up, and then I'm coming up this way. Now to look, I'm not going to read 150 because this is a small angle. So I'm going to use the outside numbers in this case. So it's hitting, okay, this line right here is 30, but I'm not quite on that line. I'm like one line over, so it's 31. But again, if you wrote like 30 or 29, you know, if you're in that zone, I'd say within 5, either way, then it's good enough. Okay, did that help clear up how to use these things? Okay, on your assignment, you've got this page that has the protractors already on there, so that, yeah, you'll do that. But what I want you to do right now is I want you to take the time, because I don't, okay, obviously we're bigger than that 90. We're opening this way, so we're going to read the 120. Okay. So that's how you'll do the first page. It's going to be, okay, acute, right, or obtuse? Acute. Now, if it's not obvious, if it's close to that 90-degree mark, you're going to want to measure it before you say exactly. Okay, I would like you guys to just try these really quickly. So 130 here and 105. Okay. This one I think was pretty hard, yeah, right? And this one was also hard. Good? Okay, any questions on this at all? All right, so for homework, I want you to do page 3 and page 5 odds. You can do the evens on page 5 for extra credit. So page 3 is 1 through 8, and page 5 is 17 through 34. If you do the evens, they're extra credit.